Imagine a storm, a swirling vortex of gases, so immense, so unbelievably large, that it could swallow our entire planet, Earth, without even a ripple. Picture our world, nestled within its boundaries, completely consumed. It's a scale that's almost impossible to grasp. That is Jupiter's Great Red Spot, a colossal atmospheric phenomenon. This gigantic storm, a swirling maelstrom of crimson clouds, has raged for centuries, defying time itself, and even now, it still shows no signs of stopping, no indication of weakening, continuing its relentless dance across the face of Jupiter. It is one of the most amazing and enduring sights in our solar system, a testament to the raw power of nature. When astronomers look at Jupiter, whether through powerful telescopes or advanced space probes, the red spot stands out like a giant scar, a permanent fixture on the gas giant's swirling surface. The Great Red Spot is not just big, it is also incredibly powerful, a force to be reckoned with. Winds inside the storm, driven by immense energy, can blow at more than 400 miles per hour, creating a chaotic and turbulent environment. That is significantly faster than the strongest hurricanes on Earth, dwarfing even the most devastating terrestrial storms. The storm's sheer size and unimaginable strength make it a fascinating and endlessly intriguing object for scientists around the globe. They wonder how such a storm defying all expectations can last so long, persisting through countless Jovian years. Many people do not realize that this storm is older than any living person, predating modern civilization itself. When you look up at Jupiter through a telescope, even a small one, you are seeing a piece of history, a glimpse into a world of immense power and ancient mysteries. This storm reminds us how dynamic and wild our solar system truly is, a place of constant change and breathtaking phenomena. Astronomers have studied the red spot, meticulously documenting its behavior for hundreds of years, amassing a wealth of data. Yet every new discovery, every fresh insight brings even more questions, deepening the enigma. Why does it keep spinning, defying the forces that should have dissipated it long ago? What secrets does it hold about the planet below, about the hidden depths of Jupiter's atmosphere? The search for answers continues, driven by curiosity and wonder with every new observation pushing the boundaries of our knowledge. The Great Red Spot is a giant storm in Jupiter's atmosphere. Think of it as a huge hurricane, but much bigger and longer lasting than any storm on Earth. It sits in Jupiter's southern hemisphere, spinning like a massive whirlpool of clouds. The color of the spot is part of its mystery. It appears red or orange, though nobody knows exactly why. Some scientists think chemicals in Jupiter's clouds give it that color. Others believe sunlight changes these chemicals over time, making the storm look red. This storm is shaped like an oval. It stretches more than 10,000 miles across, wide enough for Earth to fit inside it with room to spare. The clouds inside the red spot swirl around its center, creating a never-ending pattern of movement. The Great Red Spot is not alone. Jupiter has many storms, but none are as big or as long-lasting as this one. That makes the red spot a special feature of the planet, and a favorite target for space telescopes and scientists. The Great Red Spot, a colossal storm on Jupiter, has captivated observers for centuries. Its existence spans far beyond our modern understanding, reaching back into the annals of astronomical history. The first individuals to lay eyes upon this swirling crimson anomaly were the early astronomers, those pioneering observers of the night sky. They relied on simple, handcrafted telescopes, instruments that now seem primitive, yet allowed them to unlock the secrets of the cosmos. Some historical records and sketches suggest that keen-eyed observers may have glimpsed a red spot gracing the face of Jupiter as far back as the 1600s, a time when scientific understanding was still in its infancy. These early sightings provide tantalizing clues to the storm's true age. This potentially means the storm has been raging for at least 350 years, a truly staggering duration. And, considering the incomplete nature of historical records, it may very well be even older, a relic from a distant past. Giovanni Cassini, a prominent Italian astronomer of the 17th century, is often credited with providing the first truly detailed and comprehensive description of what we now know as the Great Red Spot. In 1665, his notes meticulously documented the presence of a giant, persistent spot adorning the southern hemisphere of Jupiter. Since those groundbreaking observations, generations of scientists and astronomers have diligently kept watch, meticulously tracking the ever-changing dynamics of the planet and its iconic, long-lived storm. Over the course of these centuries, the storm has exhibited a fascinating array of transformations. At times it appears to swell, expanding to an enormous size, dwarfing even the Earth. At other times it seems to contract, shrinking down to a fraction of its former glory. Its coloration is also dynamic, shifting and evolving from a deep intense red to a more subdued pale orange hue. Yet, despite these fluctuations, one thing has remained constant: it has never completely disappeared from view. This remarkable persistence firmly establishes it as the longest-lasting storm that we have ever had the privilege of observing and documenting within the entirety of our solar system. The sheer longevity of the red spot presents a profound scientific puzzle, challenging our current understanding of atmospheric dynamics. Here on Earth, even the most powerful hurricanes and cyclones dissipate within a matter of weeks. But against all odds, this Jovian storm defies expectations, stubbornly continuing its swirling dance year after year, decade after decade. It stands as one of nature's most enduring and perplexing mysteries, and that is precisely why generations of astronomers and planetary scientists are drawn back, time and again, to unravel its secrets and deepen our knowledge of this fascinating phenomenon. The Hubble Space Telescope, a marvel of engineering and a window to the cosmos, has been diligently watching Jupiter for over 30 years, providing invaluable data and stunning visuals. Its unique vantage point in space allows for continuous observation, free from the atmospheric distortions that plague ground-based telescopes. It gives us incredibly sharp and colorful images of the Great Red Spot, Jupiter's iconic and long-lived storm. With Hubble's advanced optics, scientists can discern intricate details within the swirling clouds of Jupiter, details that are simply impossible to spot from Earth-bound observatories due to atmospheric interference and limitations. Over the years, Hubble has provided compelling evidence that the Great Red Spot is slowly, but surely, shrinking. This discovery has sparked numerous scientific investigations into the dynamics of Jupiter's atmosphere. Historical records indicate that in the late 1800s this colossal storm was a behemoth, boasting a size approximately 3 times the diameter of Earth. Today, while still immense, it is just over 1 Earth wide, a significant reduction that continues to intrigue planetary scientists. The underlying reasons for this gradual decrease in size remain a mystery, and no one definitively knows why it is getting smaller. However, Hubble's consistent and regular stream of high-resolution pictures plays a crucial role, helping scientists meticulously track these subtle yet significant changes in the storm's behavior. Beyond its size, Hubble also reveals fascinating changes in the storm's color palette and overall shape, adding another layer of complexity to our understanding. On occasion, the red spot exhibits a vibrant, almost luminous bright orange hue, while at other times it appears remarkably pale and faded, losing much of its characteristic intensity. Furthermore, the telescope's keen eye can detect the presence of smaller storms in Jupiter's atmosphere, sometimes witnessing these smaller systems merging with the Great Red Spot itself. In some instances, these smaller storms are observed being completely swallowed and absorbed by the larger red spot, a dramatic display of atmospheric power. By carefully analyzing these intricate interactions, scientists gain valuable insights into the fundamental mechanisms that govern the storm's longevity and survival. Thanks to the continuous monitoring provided by Hubble, we have the unprecedented ability to watch the Great Red Spot evolve in almost real time. We can observe the swirling winds that drive the storm, the ever-changing colors that paint its canvas, and the mesmerizing movements of the clouds that compose its structure. It is akin to having a sophisticated weather station positioned high above, in the vastness of space, meticulously focused on unraveling the mysteries of one of the most dynamic and exciting places in our entire solar system. The James Webb Space Telescope is the newest tool for studying the red spot. It looks at Jupiter in infrared light, which is different from what our eyes can see. Infrared lets scientists peer deep into the storm's clouds and see what is happening below the surface. Webb's powerful instruments have already changed what we know about Jupiter. It can detect heat, track hidden wind patterns, and see how high the clouds rise. Webb even shows us how chemicals move inside the storm, helping to explain its strange color. With Webb, scientists have found that the red spot is colder in some places and warmer in others. This tells us about the storm's energy and how it moves. Webb also helps spot smaller storms nearby, which might feed energy into the red spot. Webb and Hubble together give us a full picture. While Hubble sees colors and shapes, Webb shows us heat and chemistry. This teamwork is helping astronomers solve the red spot's mysteries faster than ever before. Space telescopes like Hubble and Web are game changers. They let us study planets without leaving Earth. These telescopes orbit above our atmosphere so they see things more clearly than ground-based telescopes. Hubble's sharp eyes have watched the red spot for decades. It can spot changes in color and size, and even tiny storms that join the big one. This helps scientists make time-lapse movies of the storm and see how it evolves. The Webb telescope adds a new layer. It sees in infrared so it can look through thick clouds. This lets scientists study the inside of the storm, not just the top. Together, these tools are like having super-powered weather balloons on Jupiter. With every new image, scientists learn more about how storms work. Not just on Jupiter, but on other planets too. These discoveries help us understand the weather across the solar system, and even on planets around other stars. Why does the Great Red Spot keep spinning after so many centuries? On Earth, storms lose energy and fade away, but Jupiter's storm is different. One reason is that Jupiter is a gas giant. It does not have a solid surface, so storms can last much longer. Jupiter's fast rotation also helps. The planet spins once every 10 hours, making its atmosphere move quickly. This rapid movement feeds energy into the red spot, helping it survive. The planet's powerful winds also keep the storm's shape together. Another secret is that the red spot may eat smaller storms. When these smaller storms get close, they are pulled in and add their energy to the giant storm. This keeps the red spot strong and active, even as it shrinks. Even with these clues, there are still mysteries. Scientists are not sure what started the storm in the first place. They also do not know how long it will last. But every new discovery brings us closer to the answers. Recent discoveries from Hubble and Webb have excited astronomers. For example, Webb found that the red spot glows in infrared light. This means it is giving off heat, which tells us about the energy inside the storm. Hubble has seen new colors and shapes appear, showing the storm is always changing. Scientists have also found that the red spot's winds are speeding up. This was a big surprise. It means the storm is not dying. It might even be getting stronger in some ways. These changes challenge what we thought we knew about giant storms. Another finding is the presence of rare chemicals in the storm's clouds. These chemicals might be why the spot is red. Webb's infrared vision is helping scientists test these ideas by looking for clues in the cloud layers. Every year, telescopes bring new surprises. Each discovery helps us understand not just Jupiter but also how giant storms work on other worlds. That is why scientists are so eager to keep looking. Even after centuries of study, the Great Red Spot is still full of secrets. We still do not know exactly what makes it red or how it first formed. No one knows how long it will last. It could disappear in our lifetime, or keep spinning for centuries more. There are also questions about what is happening deep inside the storm. Hubble and Webb can see the top and middle layers, but the bottom is still hidden. Understanding the red spot could help us learn about weather on gas giants everywhere, even on planets around other stars. Studying the red spot matters for more than just curiosity. By learning how this storm works, we learn about the forces shaping our solar system. We see how nature creates order from chaos and how planets can be both strange and familiar. The Great Red Spot is a symbol of how much we still have to discover. As long as it spins, scientists will keep watching. Because in every swirling cloud there may be a clue to the universe itself.